Hello children, my name is Deepti. In this video series, I will revise all the chapters in mathematics following class 8 NCERT book. At the end of this series, I will give you a sample paper along with its answer key. To get your doubts clarified, you can join my Discord server whose link is given in the description box below. Now let us do revision on rational numbers. What are rational numbers? Rational numbers are the numbers which can be written in the form of P by Q, where Q is not equals to 0 and P and Q are integers. For example, minus 1 upon 33, 6 upon minus 55, 0 upon 32. All these are the examples of rational numbers. Let us now discuss the properties of rational numbers. The first property is closure property. If A and B are two rational numbers, then rational numbers are closed under addition means whenever you add A to B, you are going to get a rational number. It is closed under subtraction means whenever you subtract two rational numbers, you are going to get a rational number. It is closed under multiplication means whenever you multiply two rational numbers, you should get a rational number. But it is not closed under division because when you divide a rational number by 0, say 72, if you divide it by 0, you get not defined. So it is not closed under division. Rational numbers are closed under addition, subtraction and multiplication. The next property is commutative property. If A and B are two rational numbers, then A plus B is equals to B plus A. This is commutative property of addition for rational numbers, and A into B is equals to B into A. This is commutative property of multiplication for rational numbers. You can multiply or add in any order. You can add B to A or A to B. You can multiply B to A or A to B. Now, associative property of rational numbers. If A, B and C are three rational numbers, then A plus in brackets B plus C is equals to A plus B in brackets plus C. This is associative property of addition for rational numbers. You can add B plus C and the result you can add it to A, or you can add A plus B and the result you can add it to C. This is associative property of associative property of multiplication for rational numbers. You can multiply B to C and the result you can multiply it to A, or you can multiply A to B and the result you can multiply it to C. So this is associative property of addition and this is associative property of multiplication. Let us now discuss the distributive property of rational numbers. So A into B plus C. So this is distributive property of multiplication over addition. So first you will multiply A to B, you get AB. Plus into plus is plus. Then you multiply A to C, you get AC. Now this is A into B minus A. This is called distributive property of multiplication over subtraction. So first you multiply A to B, both have the positive sign, so the result is positive. And plus into minus is minus, A into C is AC. So this is distributive property of multiplication over subtraction. Before we solve this problem, let me add one more point to the properties of rational numbers. Commutative property does not hold true for subtraction and division of rational numbers. Similarly, associative property does not hold true for subtraction and division of rational numbers. Now let us solve this problem. It's an application of properties of rational numbers. So when you see this question, you can see 3 by 5 and 3 by 5 is common here. So I am going to interchange these two numbers position by applying the commutative property. So let us do that. So minus 2 by 3 into 3 by 5 I'll write as it is. Minus 3 by 5 into 1 by 6 I brought it here plus 5 by 2. So we have interchanged the position of these two numbers. So two numbers is for commutative property. So this is by commutative property. Now, as we have discussed, 3 by 5 is common here. So, I am going to take 3 by 5 common. So, what is left here? Minus 2 by 3. And what is left here? Minus 1 by 6. This minus 1 by 6. 3 by 5 is already taken common. Plus 5 by 2 is written as it is. So, here 3 by 5. Both the signs are negative, so you are going to get negative here. Denominators are different. So to make the denominator same, you have to multiply numerator and denominator by 2. So you get 4 by 6. This is minus 1 by 6 plus 5 by 2. So minus minus, you are adding both minus, you are going to get a minus sign. And 4 and 1 is 5 plus 5 by 2. So here which property we have used? Here we have used distributive property. So let us write down by distributive property. Okay. So let us continue solving this. So 5 and 5 will be cancelled. 3 and 6 will be cancelled. So 1 into 1 is 1 and minus is there. So minus 1 into 2 is 2 plus 5 by 2. So your denominator is same. So we are just going to add the numerator. Minus 1 plus 5 is 4. 4 divided by 2 is 2. Now let us discuss the additive identity. So as you all know, the additive identity for natural numbers, whole numbers and integers, it is 0. Similarly, for rational numbers, 0 is the additive identity. That means whenever you add any rational number to 0, you are going to get a rational number. For example, minus 3 by 6 added to 0, you get minus 3 by 6. Or 1 by 2 plus 0 is equals to 1 by 2. So 0 is called the additive identity. Now let us discuss the additive inverse. As for natural number, whole numbers and integers, to find the additive inverse, we just change the sign. So for plus 6, it is minus 6. For minus 6, it is plus 6. Similarly, for rational numbers, we just change the sign. For example, if you take minus 3 by 6, the additive inverse will be plus 3 by 6. And whenever you add the number to its additive inverse, it is 0. So additive inverse, if you take a rational number a, so the additive inverse of a is minus a. If you add the numbers to its additive inverse, you will get 0. Let us take one more example. 5 by 6. What is additive inverse of 5 by 6 is minus 5 by 6. When you add these two numbers, you will get it 0. The number and its additive inverse, they are equidistant from 0, but they will be in the opposite directions. Find the additive inverse. So first number is minus 16 upon minus 5. So here both the signs are minus, so that will be cancelled as per the division rule of integers. So it is a positive number now. So plus 16 by 5, the additive inverse will be minus 16 by 5. When you add the numbers to its additive inverse, you should get 0. 0, it does not have any sign. So here the additive inverse of 0 is 0, because when you are going to add 0 to 0, you are going to get 0. Minus 18. So the additive inverse will be plus 18, because when you add 18 to plus 18, you will get 0. So additive inverse of minus 18 is 18, 0 is 0, and for 16 by 5 is minus 6 by 5. Now let us understand the multiplicative identity. Multiplicative identity for natural numbers, whole numbers and integers is 1. Similarly, for rational numbers also it is 1. That means whenever you multiply any rational number, say a by b to 1, you are going to get a by b. Okay. So if I give you one question, for example, minus 29 upon 16 into 1 is equals to 1 into uh, minus 29 upon 16 equals to minus 29 upon 16. So which property is used here? You can clearly see that one is the multiplicative identity. That is how you are getting the same number. When you multiply 1 to any number, you get the same number. So which property we have used here? One is the multiplicative identity. Now reciprocal or multiplicative inverse. So as you have done in natural numbers, whole numbers and integers, reciprocal means you just interchange the numerator and denominator. Similarly here, if I give you a rational number, say a by b, and you multiply it to its reciprocal, say c by d, the product should be 1. It is 1. For example, 3 by 6. The reciprocal will be you interchange, or let us take 3 by minus 6. So reciprocal will be denominator becomes numerator, numerator becomes the denominator. When you multiply it, you are going to get 1 because everything will be cancelled. So this is the multiplicative inverse or reciprocal. When you multiply a number to its multiplicative inverse or reciprocal, you will get 1. Let us now do representation of rational number on number line. So the number line of rational number and integers is the same. This has got 0 here, 1, 2 and goes to infinity in this direction. This is minus 1, minus 2 and goes to infinity in this direction. So in rational numbers, we have numbers in between these two numbers as well, 0 and minus 1 and minus 2. We'll come back to that. First, let us see how to represent a rational number. You already know representation of positive rational numbers, that is similar to your fractions. So let me take one example of a negative rational number. For example, minus 2 by 5. So minus sign will tell you which side of the 0 it is. It is towards left hand side. And 2 will tell how far from 0, how many units away from 0, and for 1 unit how many divisions we are going to make, that denominator will tell. So let us make 5 divisions of 1 unit on the negative side because this is a negative number. So we are going to make 4 dots to make 5 equal divisions. 1, 2, 3, 4. Okay. So this is 5 equal divisions. That means this is minus 1 by 5. This is minus 2 by 5. This is minus 3 by 5. This is minus 4 by 5. And this is minus 5 by 5, which is 1. So your is minus 2 by 5. See, minus will tell this side. 2 means 1, 2 units away. And 5 equal divisions you have made for 1 unit. Now let us take one more number, say for example minus 11 by 5. So we are going to make 5 divisions for 1 unit. We have already finished for this. So let us make 1, 2, 3, 4 and 5. So till here it is minus 5 by 5. This one is minus 6 by 5, minus 7 by 5, minus 8 by 5, minus 9 by 5. This is minus 10 by 5. So 1 unit away from here it is minus 11 by 5. Then we need to extend this number line because you have to show between which two numbers it lies. So this is say minus 3. So minus 11 by 5, 1, 2, 3, 4 and 5. So you have to make 5 equal divisions. So this is minus 11 by 5. So this is how we represent rational numbers on number line. Now between any two given rational numbers, there are countless rational numbers. For example, as I was telling, between 0 and 1, there are so many numbers. How you can find out? For example, 0, you can write it as 0 by 10. You have multiplied both numerator and denominator by 10. Similarly, 1 you can write it as 10 by 10. So as of now, how many numbers are there between 0 and 10 by 10? It is 11 by 10. Sorry, here it is 1 by 10. It is greater than 0 by 10. Then it is 2 by 10, 3 by 10, 4 by 10, 5 by 10, 6 by 10, 7 by 10, 8 by 10 9 by 10, and then we have last is 10 by 10. So as of now, you can see only these many numbers are there. Instead of multiplying by 10, you could multiply by 100 also. So it is 0 by 100. Now this is 100 by 100. So it starts from 1 upon 100, 2 upon 100, goes till 99 upon 100. So now there are 99 numbers. Similarly, you can multiply by 1000. So you can keep multiplying. So now how many numbers you can write? From 1 upon 1000 to 999 upon 1000. So how many numbers are there now? 999. We started with 9 numbers in between, then 99 in between, now 999. So we can keep on multiplying. So there you can justify this between any two given rational numbers. There are countless rational numbers. Even the mean concept you can apply to prove that there are between two given rational numbers, there are countless rational numbers.